logically and make decisions based on the information we give it.
Right on. And by understanding these fundamental concepts, we can start to build more and more complex programs.
Okay, my coding brain is officially buzzing. Let's move on to the password generator and see how that randomness magic works.
All right, let's unlock the secrets of secure passwords. So, remember how the password generator uses that random module to create unpredictable passwords? Well, let's take a peek under the hood and see how that actually happens.
I'm ready. I'm still kind of amazed that we can make a computer act randomly.
It is pretty cool. So, one of the key functions we use from the random module is random.choice. This function lets us randomly pick an item from a sequence, like a list of characters.
So it's like we have this bag of letters, numbers, and symbols, and random.choice is reaching into that bag and pulling out a random character.
That's a great way to visualize it. And to build a password, we use a loop to repeat this process of picking random characters until we have a password of the desired length.
Ah, loops. We met those in the Countdown Timer app, right?
Yep. Same concept here. We're just using a loop to repeat that pick a random character action multiple times.
So it's like an assembly line for passwords, churning out random characters one by one until we have a complete password.
Exactly. And each of those random choices contributes to the overall security of the password, making it harder for hackers to crack.
That's really clever. I'm starting to see how randomness can be a powerful tool, not just for games, but for security as well.
It's all about using the right tool for the right job. All right, let's switch gears and delve into data management with the To-Do List app.
Okay, I'm intrigued. I love a good to-do list, but I'm curious to see how we can build one using code.
Well, this app showcases the power of lists and functions working together in harmony. Remember how we talked about lists being like containers for data?
Yeah, like a digital notepad where we can store our to-do items.
Exactly. And in this app, we use functions to manipulate that list. So we might have a function called add task that lets the user add a new item to the list.
So it's like we're creating a custom command specifically for adding tasks to our list.
Yep. And we'd have other functions like view tasks to display the list to the user and delete tasks to remove completed items.
So it's like we're building a mini operating system just for managing our to-do list.
You got it. And these concepts of lists and functions are used everywhere in programming, not just for to-do lists. They're essential for organizing and managing all sorts of data.
I can definitely see how that would be useful. It's like we're giving the computer a structured way to store and work with information, just like how we organize our thoughts and ideas.
Absolutely. And by mastering these concepts, you can start to build more sophisticated programs that can handle real-world data.
Okay, my coding brain is getting a serious workout today. What's next on our agenda?
Well, how about we roll the virtual dice again and take a closer look at the Dice Roller app?
Sounds good. I'm still kind of fascinated by how we can make a computer simulate something as random as rolling dice.
It is pretty cool, right? So remember how we use the random.randint function to generate a random number between 1 and 6?
Yeah, it's like we're asking the computer to pick a number at random, just like we'd roll a real dice.
Exactly. And the random function makes sure that each number within that range has an equal chance of being selected.
So it's not just picking a number that's convenient, it's actually making a random choice based on probability.
That's right. And that's one of the key principles behind randomness in computing, ensuring that all possible outcomes are equally likely.
That's really interesting. I never thought about how much math and probability goes into making things seem random in a computer program.
It's all about using the right tools and understanding the underlying principles. Okay, ready to move on to our next challenge.
Game on. What do we have next?
Let's revisit that number guessing game and break down how we use those if statements to create the game logic.
Okay, I'm ready to test my guessing skills again, but this time I want to know what's going on behind the scenes.
So remember how the computer generates a secret number and then gives you hints based on your guesses?
Yeah, it's like playing hot or cold with the computer.
Exactly. And those hints are generated using conditional statements, specifically if statements.
Right, so it's like we're teaching the computer how to respond to our guesses.
Yeah. So let's say the secret number is 7 and you guess 5. The code would check if your guess is less than the secret number using an if statement like this. Python if guess secret number. If guess secret number dot print too low.
Okay, so it's comparing my guess to the secret number and then deciding what message to print based on that comparison.
Precisely. And you'd have similar if statements to handle cases where the guess is too high or a perfect match.
So we're using those if statements to control the flow of the game and create those interactive hints that guide the player towards the correct answer.
Exactly. And that's how we can use conditional statements to build all sorts of game logic and create engaging experiences for players.
Wow, I'm really starting to see how code can be used to create interactive experiences that go beyond just calculations and data management.
It's all about thinking creatively and using the tools at our disposal to bring our ideas to life. Okay, let's move on to the next app and explore how we can control the flow of time with the countdown timer.
Sounds good. I'm curious to see how we can manipulate time using code.
Well, remember that time.sleep function we talked about? That's our key to pausing the program for specific durations.
Right, it's like putting the code to sleep for a bit.
Exactly. And to create that countdown effect, we use a loop to repeat a set of actions for a specific duration.
So we're basically telling the computer to do something repeatedly, with a little pause in between each repetition.
Yep. So in our countdown timer app, we'd have a loop that runs for, say, 60 seconds. Inside that loop, we'd display the remaining time, pause for 1 second using time.sleep1, and then decrement the remaining time by 1 second.
So we're essentially creating a loop that runs once per second and updates the time display each time it runs.
That's a great way to put it.
Yeah.
And once that loop finishes, we know our 60 seconds are up.
Okay, that makes sense. And it's amazing how we can use these simple concepts of loops and time delays to create something as dynamic as a countdown timer.
It's all about breaking down complex tasks into smaller, manageable steps.
Okay, my coding confidence is definitely growing. What's next on our coding adventure?
Let's travel the world from our keyboards with the Temperature Converter app.
Ooh, I love a good virtual adventure. But how does Python handle something like temperature conversions?
Well, this app showcases how we can use Python to perform mathematical calculations based on a formula. In this case, we're using the formula to convert Celsius to Fahrenheit, which is Celsius 95 plus 32.
Okay, so we're taking the Celsius temperature, multiplying it by 95, and then adding 32.
Exactly. And we can translate that formula directly into Python code using variables and operators.
So it's like we're writing out a math equation, but in a way that Python can understand and execute.
Right on. We can use variables to store the Celsius input and the Fahrenheit output, and then use arithmetic operators like pet for multiplication and plus pet for addition to perform the calculation.
I'm starting to see how those arithmetic operators are like the building blocks of mathematical operations in Python.
Exactly. And by combining those operators with variables and formulas, we can create programs that can handle all sorts of calculations.
That's pretty amazing. It's like we're giving the computer the ability to do math for us, which opens up a whole world of possibilities.
Absolutely. From simple calculations to complex simulations, math is at the heart of so much of what we do in programming. Okay, ready for our next challenge?
Bring it on! What coding wonders are we going to explore next?
Let's delve into the world of dates and times with the Age Calculator app.
Ooh, that one seems pretty intriguing. I'm curious how we can make Python understand and manipulate something as abstract as time.
Well, remember that date time module we talked about earlier?
Yeah, the one that lets us work with dates and times in Python.
Exactly. So to calculate someone's age, we need two pieces of information: their birth year and the current year.
Okay, so we need to get that birth year input from the user somehow.
Right. And then we can use the datetime.date.today.year function to get the current year from Python's internal clock.
So it's like Python is constantly keeping track of the date and time, and we can tap into that information using this date time module.
Precisely. And once we have both the birth year and the current year, we can simply subtract the birth year from the current year to get the age.
So it's a simple subtraction problem, but it's using these dynamic date time values to ensure that the calculation is always accurate.
That's right. And by using the datetime module, we don't have to worry about the complexities of keeping track of time ourselves. Python does all the heavy lifting for us.
Okay, I'm starting to appreciate how these external modules can save us a lot of time and effort. It's like having a whole library of pre-written code at our disposal.
Exactly. And Python has a vast ecosystem of modules for all sorts of tasks, which is one of the reasons why it's so popular and versatile.
My coding toolbox just got a major upgrade. Okay, what's our final app for today?
Let's wrap things up with that classic, the simple alarm clock.
All right, I'm ready to learn how to tell time with Python, but I'm still curious how we can make a computer create an alarm without any physical bells or whistles.
Well, remember that trustytime.sleep function we've been using to pause the program.
Yeah, it's like putting the code on a little timeout.
Exactly. And that's the key to creating our simple alarm clock. We tell Python how long we want it to wait using time.sleep, and then when that time is up, we have the program print a message to the console.
So it's like setting a timer and then having something specific happen when the timer runs out.
Precisely. And in this case, that something specific is simply printing a message to the console.
Okay, that makes sense. It's not a traditional alarm with sound, but it demonstrates how we can control the flow of time within our programs.
Exactly. And that concept can be applied to so many different things, from creating delayed actions in games to scheduling tasks in productivity apps.
Wow, I'm really starting to see how these simple mini apps are giving us a glimpse into a whole world of possibilities with coding.
That's what it's all about. These mini apps are just the tip of the iceberg. Once you grasp these fundamental concepts, you can start to build much more complex and sophisticated programs.
I'm feeling so inspired to keep exploring the world of coding. This deep dive has been an amazing journey, but I think we need a short break to process all this incredible information.
Agreed. Let's take a quick pause and then come back to wrap things up and reflect on everything we've learned.
Okay, we're back. And I gotta say, my brain is definitely feeling a little bit full of code right now.
Yeah, we've covered a lot of ground today.
It's incredible how much we can accomplish with just a few lines of Python, from calculators to password generators to alarm clocks.
Absolutely. And the best part is, this is really just the beginning. There's so much more we can do with these concepts.
I know, right? I'm already starting to imagine all sorts of possibilities. But before we get too carried away with future projects, maybe we should take a minute to recap some of the key takeaways from these 10 mini apps.
Yeah, good idea. Let's solidify some of these coding fundamentals.
So, what would you say are some of the most important lessons we've learned from these apps? What concepts really stand out?
Well, for me, those conditional statements were a real game changer. The way we can use if statements to make decisions within our code is incredibly powerful.
Totally. Like in that number guessing game, the way the computer could tell us if our guess was too high or too low, that was all thanks to if statements, right?
Exactly. And we saw them again in the calculator app, where the if statement determined which mathematical operation to perform. They're like the brains of our programs, helping them make logical choices.
It's like we're teaching the computer how to think. And speaking of control flow, we also encountered those loops, which seemed really useful for repeating actions.
Absolutely. Loops are essential for so many tasks, from generating passwords to creating those time delays in the countdown timer.
Right. And in the password generator, the loop kept picking random characters and adding them to the password until it reached the desired length. It's like we automated that process using just a few lines of code.
Exactly. Loops are all about efficiency and automation, and they're a cornerstone of programming.
And then there were those modules like random, time, and date time, which seemed to give us superpowers.
They really do. Modules are like pre-built toolboxes that provide us with specialized functions for specific tasks, saving us a ton of time and effort. Like in the Dice Roller app, we didn't have to write all the code to simulate a random roll. We just used the random.random function from the random module.
Right. And in the age calculator, we tapped into the power of the date time module to calculate our age in seconds, which would have been a real headache to code from scratch.
Exactly. Modules are one of the things that make Python so powerful and versatile. There's a module for pretty much anything you can imagine.
It's like having a whole library of code at our fingertips. Okay, so we've got conditional statements for decision-making, loops for repetition and automation, and modules for specialized functions. What advice would you give to someone who's just starting out with coding, based on what we've learned today?
Well, first and foremost, I'd say don't be afraid to experiment and make mistakes. Coding is all about trial and error, and the more you try things out, the more you'll learn. So just dive in and have fun with it.
That's great advice. Don't be afraid to break things and then figure out how to fix them.
Exactly. And don't be afraid to ask for help. There's an amazing online community of programmers who are always willing to lend a hand. So if you're stuck on something, don't hesitate to reach out.
It's like having a global network of coding mentors, all thanks to the internet.
Absolutely. And lastly, I'd say be patient with yourself. Learning to code takes time and practice, so don't get discouraged if you don't become a coding wizard overnight. Just keep at it, and you'll be amazed at what you can achieve.
So true. It's all about embracing the journey and enjoying the process of learning. Well, this deep dive has been an incredible experience. I'm feeling so much more confident in my coding abilities, and I can't wait to keep exploring this amazing world.
That's awesome to hear. And remember, coding is a skill that you can continue to develop throughout your life. So keep practicing, keep learning, and keep creating.
Absolutely. The possibilities are endless. And maybe one day we'll have you back on the show to dive into some even more advanced coding concepts.
I'd love that. It's always a pleasure to share my passion for coding.
Well, on that note, I think it's time to wrap up our deep dive into the world of Python mini apps. Thank you so much for joining us on this coding adventure.
It's been a blast exploring these concepts with you and our listeners.
Until next time, keep coding, keep exploring, and keep diving deep.